Okay. So optimization tayo, class. So this is like yung application ng differential or yung derivative. So this is the one of the main applications ng calculus actually is yung optimization. So we have one learning outcome is to solve optimization problems. So optimization using calculus. So introduction muna tayo. Importance of optimization. So saan ba ina-apply in real life yung optimization class? So magbigay na lang tayo ng mga examples. So let's say you will travel, 'di ba? So you have to think kung paano mo ma-minimize yung travel time mo, 'di ba? So magagawa mo 'yon by so taking route na hindi congested yung traffic, 'di ba? So you are actually optimizing your route kung saan ka man pupunta. So one of the examples yan, minimizing travel time. Another, let's say you will dress up for an occasion. Siyempre, gusto mo ring ano, 'di ba, ipakita yung personality mo through your outfit. So you can maximize your outfit based sa personality mo, 'di ba? Or pagdating naman sa pagpili ng restaurant, syempre doon tayo sa ma-minimize yung cost and kung saan mabubusog din, 'di ba? If you are being practical. So those are the examples of optimizing something, 'di ba? So generally, you want to minimize or maximize yung certain na ginagawa mo. Pero syempre sa discussion natin for today, we will be dealing doon sa mga mathematical problems. So usually involving yung mga formulas. So before we solve yung mga problems na yon, so we have your critical points class. And points where extrema occur. So what are these extrema? Ito yung extreme values natin. So yung sinabi ko kanina, yung minimum and maximum. So dito pumapasok yon. So from there, ma-optimize natin yung isang bagay, di ba? If we will get yung minimum or yung maximum value. So we need first, yung important dito actually is yung critical point. So makukuha siya, yung critical point is yung value ng x wherein magzi-zero kapag, let's say we have a function, di ba? And then we will get yung first derivative nun. And then kapag yung sinab nating x doon, and then yung value for f of x is 0, like in this equation. So f of x prime is equal to 0. So ibig sabihin, equate mo yung na-derive mo into 0. Yung value ng x na yon is our critical point. Or kapag does not exist yung sagot. Okay? So we will have example later kung paano makuha yung critical point. So yung maximum value, makukuha siya kapag yung result dun sa pag-sub dun sa x is yung largest na value, di ba? And yung minimum, syempre, yung smallest. And then, we say that an extremum of f occurs at x sub 0 if either the maximum or the minimum occurs at x sub 0. So ito yung sinasabi natin, class. We say that an extremum of f occurs. So this actually yung singular form ng extrema. Okay? So how to get yung critical point class? So napag-aralan natin class yung pagkuha ng derivative, di ba? So again, yung sinabi ko kanina dito, so we will get yung first derivative. So we have examples here, two functions class. We will get the first derivative and then get the value of x wherein magzi-zero siya. Example. So 3x squared minus 3x plus 4. So derive 6x minus 3. And then equate to 0. Okay? Kapag in-equate yan to 0, makukuha natin is 1/2. Okay? So kung 1/2, paano nakuha yung 1/2? So transpose yung 3, di ba? And then bring down yung 6. So 3/6 siya. So therefore, yung critical point natin class is yung 1/2. Wherein malalaman natin na yung critical point pala, yun din yung extreme points natin class. Wherein doon natin makukuha yung minimum at saka yung maximum point. How about the second one? So derivative nito is 3x squared minus 18x plus 15. Okay? And then, pinactor out, magiging x squared. Hold on. So letter B, x cubed minus 9x squared plus 15x minus 20. So first derivative is 3x squared using power rule minus 18x plus 15. Okay? Plus 15. And then anong ginawa dito class? Pinactor out. Factoring. So naging 3 quantity x squared minus 6x plus 5. Yung 20 class, di ba kapag derivative ng constant is 0. Okay? And then, factoring ulit dito. I mean, ginawa siyang, yung x squared minus 6x plus 5 kasi is equivalent din sa x minus 5, x minus 1. Okay? So therefore, makukuha natin yung values ng x dito. Wherein, magzi-zero siya. Pwede mong i-equate yan to 0 and then solve, you will get two values, 1 at saka 5. Or you can just directly try here kung saan siya magzi-zero. Diba kapag 5, kasi 5 minus 5, and then 1 also, 1 minus 1. So 1 and 5 yung critical points. So again, to get the critical points, derive and then equate to 0. Get the value of x. So that is the critical point. Ibig sabihin yung critical point class, dun din makukuha yung maximum value or the minimum value. Mostly factoring, yes. Pero actually pwede mong pwede mong mag-trial and error ka dito if you want. Diba? Pero to have a solution properly, you will use ito yung mga methods na to. Diba? You can sub values here na magzi-zero siya. Pero syempre kung if you will have a solution, kailangan may ganito siya. And then equate to 0. we have extreme value theorem. Okay? So extreme value theorem class is ganito siya. So let f be a function which is continuous on a closed and bounded interval. So yung na-discuss natin before. So closed interval siya ng A to B. Hindi na talaga gagalawin ng 3. What 3? Hindi siya magagalaw kasi kapag inequate mo rin sa 0 yan, mazi-0 din siya. Diba? And kapag nag-0 ito, mazi-0 din ito kasi multiplication lang. Okay, extreme value theorem. So kailangan yung function natin is continuous on a closed and bounded interval. So na-discuss natin yung about continuous functions class, 'di ba? Or continuous points. So kailangan merong naka-define na points within the interval. Okay? And then kung continuous siya on an interval class, so the extreme values, which are the maximum and minimum of f, always exist. And they occur either at the endpoints or at the critical points of f. So nakuha na natin kung paano, nalaman na natin kung paano nakuha yung critical points. So yung endpoints is actually from the interval lang. Okay? So therefore, using this extreme value theorem, na kapag continuous yung function natin dun sa interval, so we can actually use yung critical points. And yung, or either yung endpoints din. Application of extrema, yun yung maximum minimum to word problems. So apply natin. But first, suggested steps in solving optimization problems. So first, if possible, draw a diagram of the problem. Second, assign variables to all unknown quantities involved. 3, specify the objective function. So this function must be continuous. So yun nga dun sa extreme value theorem. So identify the quantity, say Q, to be maximized or minimized. And then, ito importante, formulate an equation involving Q and other quantities. So express Q in terms of a single variable, say X. If necessary, use the information given and relationships between quantities to eliminate some variables. Okay, so mas maintindihan nito kapag sumagot tayo ng mga worded problems class. And then the objective function is maximize or minimize. So yung mga problems natin involve yung mga maximizing a value or minimizing a value. And then determine the domain or constraints of Q from the physical restrictions of the problem. So the domain must be a closed and bounded interval. Yun nga dun sa extreme value theorem natin. And then use appropriate theorems involving extrema to solve the problem. So make sure to give the exact answer with appropriate units to the question. Okay, so i-discuss na lang natin ito class using problems. So disregard yung number. So first example natin, find the number in the interval -2 to 2 so that the difference of the number from its square is maximized. So first, kunin natin yung equation class. So meron na tayong interval which is -2 to 2. Okay, so sabi niya difference of the number. So gawin natin yung number na yun class is x. the difference of the number from its square is maximized daw. So yun yung ima-maximize natin. Pero we need to get first the equation. So ito yon. So tama ba? So the difference of the number, which is yung x, from its square. So tama siya. From, so ibig sabihin, mauna yung x square. And then difference, yung minus sign. Okay? So, continuous yung values natin for x sa given interval. So therefore, class, we can apply yung extreme value theorem. Diba yun yung condition? Kailangan continuous siya sa isang interval. Closed and bounded interval. So therefore, we can get yung critical number, which is as discussed before. So first, kunin yung derivative niya, 2x minus 1, and then equate to 0. Kapag in-equate ito sa 0, makukuha yung critical number na 1/2. Diba? Kasi transpose yung 1 and then over 2. So 1/2 yung critical number. And then we can also use yung interval. Ngayon, to find the number wherein ma-maximize yung difference nito, so we can just sub. So ito yung mga values. So given yung, so possible na yung extreme values nasa endpoints or dun sa critical number, di ba? As stated dun sa extreme value theorem. So isub mo na lang sila. So if negative 2, yung value is 6. Kung 2, 2. Kung 1/2, 1/4. Negative 1/4. So dito galing yung values na yan, class. Nag-substitute lang. So kung evaluate nyo to, class, so yung maximum na value ay nasa kapag yung x is negative 2, which is 6, di ba? So therefore, yung value na hinanap natin is yung negative 2. Doon siya maximum. Di ba? 6. So yung sagot is negative 2. Okay? So ginamit natin yung extend value theorem, class. So malalaman natin yung maximum or minimum. So trial and error na lang dun sa endpoints tsaka yung critical number. Okay? Another example. So ito. So if yung range R, class, which is yung distance of launch site to point of impact. So like this one. This is projectile. So yung range, so let's say nagbato ka dyan. So yung inabot niya gandun. So yung range is ito. Okay? So yung interval is 0 to 90 degrees. Ngayon, para makuha yung range, we have the formula. Initial value square divided by the acceleration due to gravity multiplied by sine 2 theta. Ngayon, yung interval ng theta is between 0 to 90 degrees, class. Okay? 0 to 90 degrees. So show that this range is maximum when theta is equal to 45 degrees. So it makes sense naman, di ba? Kung 45 degrees, so yung gitna, dun daw yung maximum niya. So let's prove. Okay. So since, class, continuous yung R natin, so R is yung range, given yung theta, class, in terms of theta. Since continuous siya, class, dun sa 0, this, naging radians lang to, class, ha. From 90, di ba dito, 0 to 90 yung interval natin. So, kinonvert lang na into radians. Di ba yung 180 degrees, class, is pi. So, therefore, kung dinivide ng 2, that is pi over 2 if 90 degrees. Okay? So kung continuous naman dito class, we can apply yung extreme value theorem. Okay? So we will get yung critical number. So derive. So pag dinerive ito class, ito lang yung i-derive since this is constant, 'di ba? Merong value yung initial velocity pati yung gravity. So therefore ito yung i-derive natin. So derivative ng sine class is cosine. And then copy yung angle which is 2 theta. And then bakit may 2 doon class? Kasi derivative ng 2 theta is 2. Okay? So kapag inequate yan into 0, magzi-0 siya class kapag yung value dito is 90 degrees. Okay? So that is pi over 2. So kung 90 degrees itong buo na to na 2 theta class, yung kinukuha lang natin is yung theta, di ba? So we need to divide pa sa 2. So kung 90 yan, divided by 2 is 45 degrees. Kung in radians, divided by 2 ito, that is pi over 4. So therefore, 45 degrees is a critical number. Ngayon, sabi sa problem, i-show daw natin na this is the angle wherein maximum yung range. Now, we compare the functional values. Yung endpoints is yung 0 to 90. So 0, 0 sila. Kapag 45 degrees class, ito yung sagot. Kasi sine 45 degree or sine 90 kasi 2 times 45 is 1. So therefore, ito yung sagot. Ibig sabihin, ito yung maximum na range na makukuha. So therefore, tama siya na yung maximum will be reached kapag theta is equal to pi over 4 or 45 degrees. Okay? Again, nakuha natin yon using yung extreme value theorem, which is kapag continuous siya, pwede natin kuhanin yung critical number, which is nandun yung extreme value, which is yung maximum in this case. Kasi pwede rin naman yung problem is minimizing class. Pero pareho lang ibig sabihin nun, you are getting yung extreme value. How about this one? A rectangular box is to be made from a piece of cardboard. So ito yung cardboard natin, 24 cm long and 9 cm wide class. So gagawa tayo ng box dito class. So di ba pag gumawa ng box, hatiin mo yung mga corners. I mean, tatanggalin mo tong mga corners na to and then itataas mo siya, di ba? So just imagine. So pinapakuha dito is yung volume of the largest rectangular box that can be formed. Kung largest yan, ibig sabihin we are getting yung maximum. Maximum volume na possible na magawa dito. So para makuha yung class, we need to get yung S. Ano ba yung maximum na value ng X, ng S na pwede? Sorry. Ayan. Ayan, bakit nag-raise ng hand? Okay, how to solve that? You may ask sa chat box your questions. Okay, so para makuha yung class, we need to get yung volume ng box na to. So paano makukuha yung volume ng isang rectangular box class? So that is length times width times height, di ba? Ngayon, paano yung magiging equation natin? So yung length nito class is actually 24 minus 2s. Bakit 24 minus 2s? Kasi kapag tinaas mo to class, di ba yung length nito is from here na lang hanggang doon. So that would be 24 minus 2s kasi dalawang s, di ba? Ito, tsaka to. That's why 24 minus 2s siya dito, yung length. For the width, 9 naman dito. So 9 minus 2s. Okay? And then yung height. Yung height is yung s, class. Diba? Yun yung mismo, yung s. Okay. So ito yung working equation natin. Ngayon, what is the interval, class? Yung interval natin is yung s kailangan between 0 to 4.5. Kasi hindi naman siya pwedeng sumagad, hindi naman siya pwedeng more than dun sa kalahati nito. Kasi wala ka nang mabubuo nun, di ba? So, 0 to 4.5. And kapag sinubstitute din yung 4.5, di ba? So 2 times 4.5 is 9. 9 minus 9 is 0. So basically, yung 4.5 na yon, class, kapag ginamit, 0 na, wala ka talagang wala kang mabubuong box doon. And syempre, kapag yung side din is 0. Okay? Pero technically, include natin siya doon sa interval natin, class, ha? So between 0 to, kumbaga yun na yung pinaka-extreme. 0 to 4.5, yung endpoints natin. Now, to get so meron siyang interval which is continuous naman doon, class. So we can apply yung extreme value theorem again. So sabi sa extreme value theorem, makukuha yung maximum or minimum doon sa critical value or doon sa endpoints. Ngayon yung endpoints is given na, yung 0 tsaka yung 4.5. Now we need to get yung critical number. Okay? So critical number makukuha by deriving. Ayan. So dito kasi, class, pinactor out niya pa yung 2. Okay? So pag dinerive yan, class, ito yung makukuha. 216 minus 132s plus 12s squared. Okay? And then, i-factor ito, magiging ganito. Then factor pa siya, magiging ganito. Ngayon, from here, class, makikita mo dito yung mga values ng s na mag-zero yung function natin. That is 9, di ba? And 2. Kasi 6 minus 6 is 0. Ngayon, hindi natin pwedeng gamitin yung 9, class kasi outside na siya sa interval. So yung 2, yung posible na gamitin. So yung critical number natin, class, is yung 2. Therefore, kapag sinabihan, di ba kanina kapag 0 at 4.5, 0 yung volume. Pero pag 2, marireach yung maximum na volume, class, which is 200. Therefore, yung S natin na hinahanap is 2 cm para dito. Para ma-maximize yung volume ng box. Okay? So S is equal to 2. Yung volume is, kung gusto mong makuha yung volume, that is 200 cubic centimeter. Okay? You can sub dito, class. Ito yung ginamit, ha. Take note, hindi dito, dun sa original equation for the volume ka dapat mag-sub. Okay? So last problem. So determine the dimensions of the right circular cylinder of greatest volume that can be inscribed in a right circular cone of radius 6 cm and height 9 cm. So inscribe. Pero isipan natin dito class, since 3-dimensional siya, what is the, kung factoring, no worries if ayaw nyo i-factor, you can just sub kung saan siya mag-zero. Okay? Going back dito, so kukunin natin yung volume, yung largest, in this case, greatest. So kung greatest, we are talking about dun sa maximum. Largest na volume ng cylinder, kapag sinabing right circular cylinder class, ibig sabihin, 90 degrees siya dito. Kapag right circular cone, 90 degrees dito. Okay? So ano daw yung maximum volume na pwede, let's say, ipapasok natin yung cylinder sa loob ng cone. Ano yung maximum na volume ng cylinder? Okay? So yung mga dimensions, yung dimensions na given is for the cone, yun yung given for the cone, 9 inches, and then dito yung radius niya, ito yung center kasi circle sa taas, di ba? Class, kapag cone yung, let's say yung sa ice cream cone, and then cylinder like yung sa canned goods, di ba? So merong circle yan sa taas. So radius ng cone natin is 6 inches. So therefore, yung height ng cylinder, given natin as h na lang. And then yung radius is r. Okay? Ngayon, we need to get function. Yung equation natin. So we will start dun sa, syempre kinukuha natin class is yung volume ng cylinder. So we will start dun sa volume ng cylinder. Ngayon, paano kinukuha yung volume ng cylinder class? So yung surface area nung nasa taas, which is circular area, that is pi r squared, di ba? Multiplied by the height. So pi r squared times height, yung volume ng cylinder. Ngayon, we need to consider class yung cone natin, di ba? So we need to get another equation. So based dun sa dimensions ng cone. Ngayon, meron tayong similar triangles dito, class. So this one and this one are similar triangles. It means ratio and proportional sila. Okay? So we will be using yung ratio and proportion doon. So kung 6 dito, class, proportional siya doon sa dito. Which is 6 minus r. Makukuha tong side na to, di ba, class? Nung triangle. Ito yung small triangle, class, and then the larger triangle. Similar sila. So yung side dito is 6. How about this one? That is 6 minus ito, di ba? Minus r. Kaya 6 minus r dito. Yung height naman, this is 9. And then unknown height. Kaya over h. Okay? Gets ba? So we have two equations. Ngayon, we need to have single valued or single variable na equation, class. Ngayon, in terms of radius na lang tayo. So kung in terms of radius class, get the equation for age here and then isub dito. Kapag ginawa mo yung class, makukuha mo tong equation na to. So in terms of R na lang. So function ng volume in terms of R. Okay? So dito, finactor out lang yung 3 pi R square. So ito yung working equation natin, class. Ngayon, alin yung interval natin dito, class? Yung radius yung pinag-uusapan natin dito, di ba? So ibig sabihin, yung interval natin dito, class, is yung radius ng cone. Kasi dun lang yung ano natin, limit kumbaga. And that is 0 to 6. Continuous naman yung volume natin sa 0 to 6, di ba? So we can apply yung extreme value theorem kanina. Okay? So alam niyo naman, we need to get yung critical number. Kasi baka nandun yung extreme value. Diba? So derive. Kapag dinerive ito, class, that is 18 pi r. And then bring down yung 3 dito, 9 over 2 pi r squared kasi minus 1. Ngayon, finactor out yung 9 pi r dito para mas madaling makuha yung critical number. So, the critical number is actually 4. Kasi 4 divided by 2 is 2. 2 minus 2 is 0. Pero yun nga, pwede kang mag-trial and error if you want. So, kung 4, isam mo dito, mag-0 siya. Okay? So, again, comparing the values, kapag 0 to 6, 0 yung volume natin, class. Pero kapag critical number, we will reach yung maximum volume, which is 48 pi. So, therefore, class, yung R pala dito ng cylinder is 4, which is actually here. May nagsabi kanina, student, ito pala yung ibig niya sabihin na hindi, kumbaga parang hindi siya realistic here. Anyway, baka mali lang yung ginamit na dimensions. Yung R dito is 4. And then age is, kung kukuhanin yung age dito, sub yung 4. So 6 over 6 minus 4, that is 2. So 3. Cross multiply, 3 age, bring down yung 3, 9 divided by 3. So age natin, class, is 3. So therefore, yung dimensions ng cylinder is R is equal to 4, age is equal to 3. Okay? Wherein yung volume nun would be 48 pi. Dito, you can sub dito yung R na 48 pi. Okay? Again, yung tinatanong dito is yung volume, di ba? Yung sagot natin is maximum volume would be 48 pi. Pero kung tinatanong is yung dimensions, that is R radius 4 and then height is 3. Okay? So, ito yung application ng derivative class. So, you can get yung maximum or yung minimum ng isang, let's say, variable. So, when you are getting yung maximum or yung minimum, we are actually maximizing or we are actually optimizing something, di ba? That's why this is all under optimization, which involves yung derivative. So this is one of the main applications ng calculus class.